Right, in this video we're going to be looking at parameter A and the effect that it has got on the parent graph when the parameter has been changed. So our parent graph, our A is equals to 1, and we're going to be comparing it to A is equals to 2 and when A is equal to 4. So let's begin. When we are comparing these two graphs, obviously we're using the table method. When we've got -2 here and we've got -2 there, the y value for the parent graph is -half. The y value for where we're having a bigger A, it's -1. And between -half and -1, we all know that -half is bigger than -1. Okay, and then when we've got -1 and there's -1 there, our y value is -1 and our y value here is -2. Once again, our y value on the parent graph is bigger than when the A is bigger. All right, let's see the positive numbers to say that does it remain like that. Now, when we've got x as a +1 on the parent graph, our y value is 1. When we've got x as 1 where A is equal to 2, our y is equals to 2. So for the first time, we are getting we've gotten a y value which is bigger than the parent graph. So we can conclude that if we're having the parent graph and our A is more than 0, the negative values, the bigger the number, the bigger the value of A, the smaller the y values, right? And the smaller the value of A, the bigger the y values. We saw it with the given coordinates. Now, let's check number 2. Now, when our x value is equal to 2, the y value is 1/2. And when our x value is 2 here, our y value is 1. And once again, 1 is bigger than 1/2. So we can conclude that when your A is more than 0 and your x values are positive, then the y values that you get, they will be bigger, right? They will be bigger compared to what? Bigger compared to the parent graph. They will be bigger to the parent graph. However, let's observe another thing. Do you see that here 1 is smaller than 2, but the y value for 1 was bigger than what? Was bigger than the y value of when x is equals to 2. So let's see if there is something else interesting here that we can conclude. So let's make our x to be what? To be 3, where our A is equals to 2. Then now, when we go, we're going to substitute. In other words, we are having 2 over what? 2 over 3. And 2 over 3 obviously is smaller than what? It is smaller than 1. So when we stop comparing to the parent graph, we're now just comparing the values here for this graph of y is equals to 2 over x. We can now conclude that, as a matter of fact, our y values, they are becoming smaller and smaller. So let's see what it means graphically. Here it is here graphically. So let me just raise it up a little bit so that you can be able to see the values. Okay, so to confirm, when our x is +1, our y is 2, and that graph, when our x is what? When our x is 1, our y is +2. There we go. And when our x is 2, our y is 1. And here, when our x is 2, our y is 1. So we can see that this graph is actually what? It's decreasing. It's decreasing. That's what's happening here. It's decreasing. All right. And let's check here. Let's check the negatives. When our x was -2, our y was -1. When our x for this graph was -2, our y was -1. There we go. And when our x was -1, our y is -2. So on this side, it's decreasing. In this third quadrant, it is also decreasing. So we're moving from higher y values to smaller y values, right? Let's see if this pattern is maintained when we now examine the graph of y is equals to 4 over x, right? When I've got negative 4 and as my x value, I've got a y which is negative 1. When I've got a negative 1, and obviously, why did I jump some coordinates of x? Negative 3 and negative 2 would have given us fractions, and then it would have been a little bit difficult to plot here. So that's why I chose numbers which are easier to work with, which do not provide fractions. So when we've got negative 1 and negative 1, remember it is bigger than negative 4. Let's look at the y value. The y value is negative 4, right? Which is smaller than negative 1. When we go to positive 1, our y value is 4. When we go to 4, our y value is 1. And once again, what we have observed on this graph, guess what? It's happening here as well. Our values are decreasing. So if we come to the graph where and we start negative 4 and negative 1, here is negative 4 here. When our y is negative, when our x is negative 4, our y is negative 1. When our x is negative 1, our y is negative 4. So it is decreasing, right? It is decreasing in this third quadrant. And then when our x is positive 1, our y is positive 4. And when our x is positive 4, our y is what? Positive 1. So it is decreasing, right? So what conclusion can we draw here? Now we can draw that the conclusion that as the value of a gets larger, the branches of the hyperbola are stretched away from the x-axis. Let's look at that. This one in black, this is the graph of y is equals to 1 over x. Now, what do you see? This graph is closer to the x-axis here. This is the x-axis here, and the graph of y is equals to 1 over x. It is closer to the x-axis. The red graph here, it is what? The graph of y is equals to 2 over x. And if I compare these two, you can see that this is further away from the x-axis. It's far away compared to the black graph, right? And when I get to this graph, which is y is equals to 4 over x here, you can see that it is further away than any of these previous two graphs, right? Even if I come to the third quadrant, you can see that here there is a bigger gap between this graph of y is equals to 4 over x, and these other, compared to these other two graphs, right? All right. So I hope that makes sense. Now, the other thing that we need to explore when our a is negative. When our a is negative. What do I mean by that? If you check here, we're going to use the opposite. Here where y is equals to 1 over x, here we're having y is equals to negative 1 over x, right? Here where y is equals to 2 over x, here we're having y is equals to negative 2. So in each instance, where our a was equal to 1, we are saying that on this graph, our a is equals to negative 1. Here, we are now having our a, which is equals to negative 2. And there we've got a, which is equals to negative 4. Now, let's observe. When our x value for the parent graph was negative 2, we had a negative half. And if we come here, when our x is negative 2, we've got what? We've got a positive half. So let's go and plot that, right? So our negative 2 is here, and we've been told here that our y is half, meaning to say that when we are having negative 2 here, our y is somewhere here, right? And when our x is negative 1, we've got a positive 1. When our x is negative 1, our y is a positive 1 there. Let's explore. When our x on the parent graph was negative 1, the y was negative 1. So when the x was negative 1, the y was here. Now, here we plot our graph. It looks like this. It's supposed to be a curve. It's not supposed to look like a right angle. So what do you see? This in this third quadrant and this second quadrant, what has happened is that this black graph which is here, it has been what? It has been reflected on the x-axis, and now what was in the third quadrant, it is in the second quadrant. Now we are going to explore our positive x values. When our x was 1, our y was 1. When our x was 1, our y was 1. Let's see with this one whereby it's negative. When our x is 1, our y is negative 1. Meaning to say that when our x is 1 here, our y is negative 1. And you can see that this is the reflection on the x-axis, because when the x was positive 1, the y was positive 1. Whereas it's now being found here on the negative 1. Let's check. When our x here was positive 2, we had what? A half. And here when our x is positive 2, our y value is a negative half. So when we're having a positive 2 here, our y is half. So let me just erase here and put a half here. So in other words, I'm just going to erase this so that I can draw the graph, the arc, or the branches rather. And just like that, you can see that this in quadrant 2 here and quadrant 4, they are the reflection. This one is the latest reflection of what? Of the graph of y is equals to 1 over x, right? So this is reflected here, and that was reflected there. This is the graph of y is equals to negative 1 over x. So if you can try and plot all of these, what do you call this? You can pause the video, take these values and plot for yourself, and you'll see that what will just happen is that this red graph here is going to be also translated. Remember, okay, let me put it this way. From your grade 9, you were taught that when there is a reflection on the x-axis, what happens? Your y values, they change. The y values change. So if I was given the coordinate 2 and 4 here, and then we are being told that it reflects on the x-axis, what changes is the y value, meaning to say that my x remains the same, my y becomes a negative 4, right? So let me show you something about this red graph without having to constantly go to the table method. When my x here was positive 2, my y was 1. Now remember I said that the y changes. So the opposite of 1 is what? Negative 1. So now I'm saying that here where there is 2, then my y is here. Then here when my x was positive 1 for this red graph, my y was 2, which means the y has changed. It's no longer positive 2, it's now negative 2. So I come and I draw it, my plot here. Then from there, I join these points which I've plotted, and you can see that this, what do you call it? This branch here is identical to the branch there, right? So basically, whenever you are given, let's say you are given y is equals to 2 over x and y is equals to negative 2 over x, the reflection is happening on the x-axis. So whatever values which you're having here on this table, you just go and what? You change the y values, and all of them, they become what? Negative y values. They become negative y values, right? So those are the effects which happen when you change. When you change what? When you change your a. When your a is less than 0. And the conclusion here, we simply say conclusion. The value of a negative, wait a minute. The value of a negative a represents the reflection in the x-axis. and x is equals to 0 is a vertical asymptote and y is equals to 0 is a horizontal asymptote, meaning to say that if you observe all the graphs that we have here, none of them have touched this x-axis, none of them have touched this y-axis, meaning to say that these broken lines which are in red, they are representing what? They are representing an asymptote. So here you write that x is equals to 0, and here at the bottom you write y is equals to 0. When you did that, you are telling the examiner that I've got this asymptote which is a vertical line, and I've got this asymptote which is a horizontal line. I hope this makes sense. Let's meet on the next video where we talk about the value of q. Remember, now the equation will be y is equals to a over x plus q. So we must investigate the influence of q on this hyperbolic graph. If you found this video to be helpful, please do consider to subscribe and join us in our journey of passing pure mathematics. Thank you.